Assalamu alaikum. Today we are going to start by Chapter 3, Vectors Generalities. In this video, we will define a vector and specify its components, represent and denote a vector, define a zero vector, opposite vectors, and equal vectors. Get ready and prepare your textbook, pens, draft papers, copybook, and calculator. First of all, what do we mean by a vector? A vector is a translation from one position to another, and it is characterized by three components: direction, sense, and magnitude. What do we mean by these components? If we have a translation from point A to point B, this means that we have vector AB as shown in this figure. We have a translation from A to B, and this is vector AB. This vector is denoted by capital A, capital B, and a small arrow above it. The components of this vector are the direction, sense, and magnitude. Its direction is the line holding this vector, which is line AB or any line parallel to it. The sense is from point A to point B, and the magnitude is also called modulus or norm, is the measure of length of segment AB. Example: if we have a rhombus ABCD of side 5 cm, we need to find the components of vectors AD and BD. The components, as we said, are the direction, sense, and magnitude. Let's start by the vector AD. The components of vector AD are the direction, which is line AD or any line parallel to it, the sense from point A to point D, and the magnitude, which is the length of segment AD, 5 cm in this case. Now vector BD, the direction of this vector is the line holding it, which is line BD or any line parallel to it. The sense is from point B to point D, and the magnitude is the measure of segment BD, which is not stated in this example. Equal vectors. If we have two vectors U and V, these two vectors are said to be equal if they have same direction, same sense, and same magnitude. What do we mean by same direction? We mean that these two vectors must be on same line or on parallel lines as shown in the figure. Here we have vector U and vector V. They are on same line, then they have same direction. Here we have vector U and vector V. They are on parallel lines, then they have same direction. Same sense means that if one vector is going to the right, the other must also go to the right. If one vector is going upwards, then the other must also go upwards. And same magnitude means that we must have the same length of segment. Example: if we have segment AB of midpoint M, we say that AM vector is equal to MB vector because they have same direction, same sense, and same magnitude. But how? Same direction because they are on the same line, since A, M, and B are collinear. Same sense, since from A to M, as from M to B, they are both going to the right. And same magnitude, since AM, length of segment AM, is equal to length of segment MB, since M is the midpoint of segment AB. Another example: given a parallelogram ABCD, we need to find two pairs of equal vectors. We can say that AB vector is equal to DC vector because they have same direction, they are on parallel lines, same sense from A to B as from D to C, they are going to the right, and same magnitude. The length of segment AB is equal to the length of segment DC since they are opposite sides in a parallelogram. Another pair, vector AD, is equal to vector BC since they have same direction, they are on parallel lines, they have same sense from A to D as from B to C, and they have same magnitude. The measure of segment AD is equal to the measure of segment BC, opposite sides in a parallelogram. Application 1. Pause the video for 5 minutes and try to solve this application alone. In this application, you have ABCD is a square of center O. Part 1, they said name 3 pairs of equal vectors. Remember that equal vectors means that they must have same direction, sense, and magnitude. You need to find 3 pairs of vectors that have same direction, sense, and magnitude. We can say that vector AB is equal to vector DC. Since they are on parallel lines, so they have same direction, they have same sense, and they have same magnitude. Also vector AD and vector BC. Also they have same direction, sense, and magnitude. You can say also that vector AO is equal to vector OC. Since they are on same line, then they have same direction, they have same sense, and they have same magnitude. There are also many equal vectors, just like DO vector is equal to OB vector, and etc. Part 2, they said check if vector AB equal to vector AD. Here is vector AB and here is vector AD. These two vectors are not on parallel sides. They are not also on the same side. Then they have different direction. So no, they are not equal vectors since they have different directions. Part 3, check if OD vector is equal to OB vector. These two vectors are on same line, then they have same direction. But the sense from O to D is different from the sense from O to B. Then they have different senses. So these two vectors are not equal. Part 4, are the vectors AO and AC equal? They are on same line, then they have same direction. They also have same sense, but the magnitude of segment AO is different from the magnitude of segment AC. Then these two vectors are not equal since they have different magnitude. Opposite vectors. If we have two vectors U and V, they are said to be opposite if they have same direction, same magnitude, but opposite senses. As shown in the figure, vector V and vector U are on same line here, so they have same direction. They have also same magnitude, but they have opposite senses. Vector U is going to the right, while vector V is going to the left. In the other figure, here you have vector U, and here you have vector V. They are on parallel lines, then they have same direction. They have also same magnitude, but they have opposite senses. Remark: if U and V are opposite vectors, then U vector is equal to minus V vector and vice versa. Another remark: the two vectors AB and BA are said to be opposite. We can write AB vector is equal to minus BA vector. Example: we have segment AB of midpoint M. We say that MA vector and MB vector are opposite. Here is MA vector and here is MB vector. These two vectors are said to be opposite because they have same direction since they are on the same line. They have same magnitude since the measure of segment MA is equal to the measure of segment MB because M is the midpoint of AB. But they have opposite senses. MB vector is going to the right while MA vector is going to the left. Another example, we have ABCD is a parallelogram. We need to write two pairs of opposite vectors. We can say that AB vector and CD vector are opposite vectors because they have same direction, they are on parallel lines, they have same magnitude since the measure of segment AB is equal to the measure of segment CD, but they have opposite senses since AB is going to the right while CD is going to the left. So AB and CD are opposite vectors. Also AD and CB are opposite vectors because they have same direction, same magnitude, but opposite senses. Application 2. Pause the video for another 5 minutes and try to solve this application alone. In this application, you have ABCD is a square of center O. Part 1, you are asked to check if AB and CD are opposite vectors. Here is AB vector, here is CD vector. These two vectors have same direction, they are on parallel lines. They have same magnitude since the measure of segment AB is equal to the measure of segment CD, opposite sides in a square. But AB is going to the right and CD is going to the left, so they have opposite senses. we can say that yes, they have same direction and magnitude but opposite senses. Part 2. Are the vectors DO and OB opposite? This is DO and this is OB. These two vectors have same direction, same magnitude and same sense. So they are equal vectors, not opposite vectors. Part 3. Are the vectors AC and CO opposite? This is AC vector and this is CO vector. These two vectors, they have same direction, they are on same line. They have opposite senses, but they have different magnitudes. So they are not opposite vectors. Zero vector. A vector is said to be a zero vector if it is a translation from the point to itself. Therefore, if we move from point A to point A, this means that we have AA vector. This is called a zero vector. Notation: zero vector is denoted by a zero and a small arrow above it. Remark: if U vector is a zero vector, then the magnitude of this vector is 0, but we cannot know its direction and sense. AA vector is equal to BB vector is equal to CC vector is equal to DD vector is equal to 0 vector, since AA vector is a translation from A to itself, BB is a translation from B to itself, and etc. If AB vector is equal to 0 vector, then this means that A and B are confounded and vice versa. At the end of this video, you are asked to revise the course section parts 1, 3, 4, 5, and 6 in your book and solve exercise 1.